Alrighty, hello everybody, and welcome back to the channel. Today we're in Stormworks. We are getting ready to plant the oil well, and I thought, you know what? After that, we're going to go to space. So I thought, let's do a preview of some of the things that we're going to be coming up. And of course, our special guest tonight is Bim. He's just sitting in the lap tonight, and he really likes it. So what I've done is I've got the astronomy sensor and I put it into the microcontroller. And then what I want to do is I want to output some numbers, the X, Y, and the Z position. And I just want to see a couple of things, X, Y, and Z. So now we'll think about it like this. So X is your north-south. Y is your elevation. And your Z is your east-west position. That's the easiest way to understand this alignment. So now inside X, Y, these are going to be outputs. X, Y, and Z. And we've got our composite number. Channel 1, Channel 2, and Channel 3. Alright, so we can update that. Then what we need is a altimeter. We need to know the elevation, so we can compare that to the number that we're getting. And then we'll send this into there. And to read the numbers, I'm just going to send them into a dial. And we should be able to read that number. And then this will be X, and this will be Y, this will be Z. So remember, this is our north-south. This is our elevation, and this is our east-west, right? This is how we're going to keep track of our movement around the map. It's spun over. All right. So our 13873 is our X position. So if we go into our map and we look at our X position, you can see it's really close. And the Y position is 2875. That's actually the Z position. Oh, they're all three the same. Channel 1, channel 2, oh, whoops. There we go. Let's try that again. So the X position was correct, and then the Y position, yeah. It's pretty much right in where we are. So that is accurate. Coming off the astronomy sensor, that is our current position and our current elevation. So we don't even need, with this setup, we don't even need, there we go, right? So now that we know our current position, we are now able to move around in 3 dimensions, right? We're able to measure our elevation and our distance off of where we begin. So that's the next part that's really important, is what we need to do is we need to save these numbers. Right? Now what we need to do is we need to say, okay, if I want to go north, I want to measure that off of my current position so I know how far north I'm going off my current position. So we need these memory registers. Now, what I'm told is how these things work is they need a constant, is it a constant on signal? Or is it a pulse? Let's see. Remembers the input value when receiving a signal to the set node. So I'm interpreting that as it needs a constant number. Of course, I think I went over this last time and I was wrong. So I want to see if I might be correct. So then let's do that. And then what we're going to do is we're going to try and move it. So if we update that and spawn it in. So right now it should be set to this current position. And then if we move it, you see it's moving as well. So let's try a push button. All right, and then we'll do an input into here. And this will be set. All right, and then we'll update that. Need a battery. See if that works. So now if we press the button, it should set our current position. And now when we move, you see, that position is now saved in the memory, quote unquote, it's saved. So now what we can do on the opposite side is we can output the difference between this number and the other numbers. So what we need to do now is, let me see, I think distance is something divided by something. Just a moment here. Consult Google. Goggle. It's my brain. That's what they want. They don't want me to have a brain. They want it to be Google. So I'll use Google. Then if my phone ever breaks, I won't know how to do anything. Then I'll have to get a new phone. Otherwise, I won't have Google. Let's see, distance calculator, formula. What's going on here? What is going on here, neighbors? Okay, so distance is this number. Okay, so let's do this together. So what we need is a minus. You know, we could probably do this in a function block. Actually, let's take a function block. We're gonna need 1, 2, 3, 4. We're gonna need the 5. I think it's this one here. All right, and then so what we're gonna do is we're gonna take numbers 1, 2, and 3, 4, 5, and 6. Now, oh, that's our distance to our, okay. That would be like a direct line, right? No, that's not what I'm trying to figure out. I guess it doesn't really matter. I just have to subtract that from that, and then that'll tell me how far I've moved. And then I guess it's in meters, right? So yeah, I don't need this yet. I'm going a little bit too far ahead of myself here. So basically I just need to subtract these numbers, this number from that number, and then whatever the distance is the linear distance that I've traveled in that direction. So for that we just need this, we'll need 3 of these. Right, and this is going to be X, and this is going to be Y. X and Y. X and Y. And then inside, we're just going to say function X minus Y. Actually, we need some. We need the sum over here. Operators, X minus Y. That's it. X minus Y. Perfect. All right. X minus Y. So that's what we do. And then the final number we can send out. All right. So let's just do this for a moment. So now we can set the number where we're at. Uh-oh, something's going on. What's going on? Oh, I did something different. I need 3 more outputs. X, Y, so this is going to tell me how far off of our starting position we have traveled. X, Y, and Z. So that's going to be this one here, X, Y, and Z. So now when we update it, we're going to say I should reverse those. Because I've already got them set up for this, right? We've already set it up. So let's do that instead. And then we'll set up new XYZ for that, right? X. Oops. X distance, Y distance, and then this will be Z distance. Oh, what can I do? All right, perfect. Now, if I spawn that in, this is our current X, Y, and Z position. And this is the distance we've traveled off of that position in real time. Now, that, I guess, is in meters. Yeah, that's kind of perfect, actually. If we go way over here, I think we're moving. I think we're moving. Yeah, not very much, not very much. Well, you kind of get the idea. Now it's sort of moving on its own. That's cool. Look at that. Look at that. It's moving on its own. Oh, it stopped. Yeah. So now if we go to space, we'll be able to measure off of where we take off and we start to head up to space. We want to mark that position, that XY position. And then when we get into space, we'll know from there where our next XY, how far off of that we've gone, right? To get into space. So all it does is just gives us a point of reference. So if we take this, let's see, if we take this microcontroller and we copy it, and then if I load, let's see here, what do we need? We need the space plane, and then if I load the space plane, and I put this on it, now I think there's an astronomy sensor on here. Oh, I thought there was. Alright, so we can take that astronomy sensor, we can put it into there, and then we need, we're going to need a couple of dials. You know what, let's see. Let's get a monitor. We'll get a 1x1 monitor. Alright, and then it needs electricity. It needs video. It's going to get from there, and then it needs to be turned on. Let's systems. Okay, so we turn that on. That turns on. So then in here we want to have a Lua block. Not that one. Inside this one here, we want to add a Lua block. Now, what I need is some code. There we go. Alright, so if you're wondering what I'm doing is I'm just taking some draw code, and we'll get rid of that, and we'll do that. Okay, so what it's going to do is it's going to draw a text box, and then it's going to have this reference. So we need to find out what that is. That's going to be our X. Alright, so we're going to do this. We're going to copy that, and this is going to be Y, and this is going to be Z. And then here what we need is we need to say X equals input dot get number, and it's going to be channel 1, and then we're going to say Y equals input dot get number channel 2. This is going to be Z equals input dot get number 3. Alright, X, Y, and Z, and then now in 1, down 1, and it's 6. So this should be 8, and then this could be 15. Alright, so then we need a composite read number, write number. It needs to have 3 channels in it. That needs to go into the Lua block. We need a video out. And then we need the Lua to connect to the video out, and then I want to just see what else it's printing. I don't know what color that is. We'll change that. That's good. Oh no, it's not good because as you can see, it's over 60. Is that XY? What is it? Text box? Text box. Width and the height. Yeah, it's 32 by 32, so this should be 32. Could be 30 even. There we go. Alright, so we'll see how that looks. We want the distance. Distance X. Distance Y. Distance Z. Really, that's the only number that we need. We don't really need this coming. I mean, we could get our current XYZ, but we'll be able to look down at the astronomy. Oh, we can't get it directly from the astronomy sensor. So maybe what we do is we expand this to 6. And then in here, we need to take this 3 more times. And then this will be like X current. Let's see, that's 15, 22, 29. Oh, that's not going to work. It's 32 by 32. Well, if it's 6 here, we'll tighten this up. 7, let's say 14, 21, 28. That's still not gonna work. Let's try it. Let's try it. Let's try it. That's not gonna work. The bottom one is gonna be off. Okay, and then we need to copy this and X current Y. Let's see, X current Y current Z and then Y current. There we go. This will be 4, 5, 6. All right, so let's check to see if there's any errors. No errors detected. Okay, and then we can have our saved distance. 0.00. 1, 2, and 3. So there's going to be one. We're going to need to have one more element on this. Let's just see what this looks like. And then I'll explain what I mean by one more element on this. It has power. What's going on? Did I forget to connect the video? Probably forgot to connect the video. Yep. Forgot to connect the video. Eventually, I want to be able to dock this space plane to a space station. I think that'd be rad. That'd be so cool. That argument number 2, format number expected got nil. Huh. Hold on, let me look at that error one more time. Oh, let's get some music rolling. Let's get some music rolling. Cue the tunes, DJ. Line 20. Line 20. Right there. Spelling. Yeah, so it'll tell you what line the error is in the code. And then you just have to kind of go, huh? Huh? But it's right. How could it be wrong? There we go. So that's our current X, Y, and Z, and then that would be our distance off of X, Y, and Z. So if we went to... Oh, I'll turn the brakes off. But you notice how it's not changing. Now, why is it not changing? It's not changing because we haven't set our distance. So now we need a button that will set our distance. And I think I'm going to run this one off the seat. And this could be numbers. Oh no, the seat is for that. Alright, let's see if we can see this toggle here. Yeah, there we go. And I mean, that can just be, it can be on. It doesn't even matter. Oh no, it can't be, it needs to be a push button. It can't be a toggle button. It needs to be a push button. Or else it'll be constantly updating our X, Y, and Z, and we don't want that because then we will truly get lost in space. We've been traveling for light years, Captain, and our distance is still at 0. I'm not too sure what to make of it. Yes, maybe we should consult the engineer, and he can tell us what's wrong. Alright. There we go. Now it's the opposite, right? So what I'll need to do is I need to put in a bigger monitor. Maybe I'll get rid of this because we don't need the rotation anymore. We now have our distance off of our current position. So it kind of matters how we rotate, but this becomes less important now, and it's the distance that becomes more important. So the rotation will eventually matter when it comes to applying force on the axis that we need, X, Y, and Z, to get to these positions. So that's going to be kind of the final part here, right? Is now we need to connect these two together and figure out, okay, so do I make one screen and then we have a dot in the middle, and that is our current X and Z position. And then on the side, we have our Y position, up and down, you know, and the distance would be there to the moon. And then what we need to do is, for our X and our Z position, we need to, we'll need to spin, right? And then force in the right direction. So either they'll start off the center and move based on that distance. Yeah, we could actually do that. We could probably scale it. We could scale it to a radius. Ooh, that's exciting, actually. Then we could build like a whole interface. And then I don't think we need this, because this is also our current X, Y, and Z. So we can replace this. This whole dashboard now can be replaced. Oh my goodness, that's exciting. What time is it? It's only midnight? Yeah. The whole dash can be replaced. So we can get rid of this. This was our rotation, and it needs to be recalibrated. Cool. It needs to be recalibrated because I don't know what that was. Let me. Distance X. Oh yeah, but it's your distance off is 0, 0. So it was just way too confusing. What we needed, we need the 0, 0 to be where the spaceship launches into space. Because when you think, for example, if we travel from here to the moon, we want to be able to measure how far off of our X and our Z from where we launched to, not from the 0, 0 on the map, right? So currently when you look at the Stormworks map, 0, 0 is like in the center of the map, and we're way off to the side, right? So anyways, yeah. Oh, that's perfect. That's exactly what I mean. Okay, so now what I need to do is we need to replace this. So these rotations, we'll have to print them in a different way. And these numbers too. And I don't know what that was, hold position. All right, and then this dial here is our, what exactly? Linear speed. All right, so we can get rid of that. Then we want a monitor. I wonder if we can do like a 2 by 3. That's cool. And then we can put some panels in there, just to give us some. We could put a panel there and a panel there, and then we could get indicators. Just blank indicators for now. Eventually they will be, yeah, that's kind of cleaned up. So now what we need is a systems is going to turn that on, and then our video, we're going to feed from this input. I don't know what that is. Square root X. Oh, that's X, and then what is this one's Y? Is that what, how big this thing is? Whoa, what's this one here? The rocket thrusters. Oh, this is the speed, right. Now, the thing about the speed is that it only gives us thrust. It's not actually our speed, it's our thrust. So now that I'm able to calculate our distance, I'm also able to accurately calculate our speed, which we will add in there. Okay, so I'm just trying to see if I still need these, if these are still relevant or not. Temp, oxygen, I guess this one is probably, but I don't have it hooked up. It's probably thinking something else here. Oh yeah, that just comes in from the astronomy sensor. Rotation sync. Oh, that must have been for the satellite. Interesting. I wonder why that's on here then. Am I using anything else in it? Just the Euler angles, that's it? Oh, I see. And then I can put in where I want to go to. See, it's going to be easier. It's actually going to be easier. We're going to redo that. So let's get rid of this one. Let's get rid of this one. Let's get rid of the astronomy sensor. I hope I'm not deleting too much. Okay. So everything we want. Oh, no, I can always get that again, that rotation. Everything we want is gonna kind of come out of this one here. Right. So then, I was thinking the calculation for speed, and that is the speed formula. Is distance divided by time. So what we can do is every logic tick, we can say x minus x current equals distance x. X, Y, Z. Now, I don't think I can write it this way. I think I have to write it the other way. And I think this is where sometimes I run into errors. Is in Stormworks, we need to write the variable and then what the variable equals. I could be wrong, but I think that's how we make the code work. All right. X, Y, Z, and then we can say speed X, Y, and Z equals distance X divided by I wonder how we would get. What's the speed of a tick? Probably pretty fast, eh? So I know I was dividing it by 3 seconds. I would let it wait 3 seconds, and then it would. But if we have our current distance. Yeah. Because what we have to do without this, it's going to be delayed, but then we have to mark. Yeah. Let's see. So it's distance divided by time. I don't know what we don't have a timer. So I don't just want to divide it by 2 because that doesn't make sense. So we would have to say, yeah, there needs to be a delay in here somewhere. Wait 1. So speed equals yeah. I wonder if we could wrap it in like while true. While true do. Or we could say if, probably needs to be an if statement. If input dot bool 1 true, then I think then speed x equals let's see, how's this going to work? Because we need the distance divided by the time, so we need to it's way too late in the night, I think, for me to be getting into this. Where are we at here? Where are we at here in this video? 42 minutes. All right. Yeah, so there needs to be, so before we can get to here, what I'm trying to say is there needs to be a delay. So if we want to calculate, we need distance, yeah, x, we need to divide, subtract, x, distance divided by time. So we need to subtract this from this. That'll tell us how far apart we've gone. So we need subtract. And we need to subtract this number from this number. And if we turn this to 9 channels, so that is our current distance. That would be our live distance on X. Y and Z. Now, what we need to do is we need to set up a timer. And then we need a constant number. And we can set that to 1. And then we need like a blinker. I don't know if we can make a blinker. Oh, we do have a blinker. Okay, so then we need a blinker. And that will turn that on. And the blinker will blink every second. And that should give us... Okay, so then every second we need a number switch. Every second it's going to turn on. It's going to give us this number. And we should be able to use that. So let's try and see if we can get that number there. Just to see it. It'll be flashing. Videos on the screen, monitors connected, there's power to it. There's no power to it. All right. Yeah, just kind of a preview. There's going to be a lot of thinking and a lot of stuff coming up to get. We're going to have to rely a lot on code to help us to get to space. It'll be the easiest thing. So it says syntax error near end, line 18, of course. Because I didn't finish the code. So we won't worry about that yet. There we go. Can we do that? There we go. That's not working. What's going on here? Oh, it needs an on signal. It needs an on signal to work. We have this constant on signal. It needs this on signal. Now, it either needs to pulse or it needs a constant signal. Let's figure that out. Yeah, it's going to take a lot of science to get back to space. Okay. So is this supposed to be the first number that's 0? Yeah, it's supposed to be that first number that's 0. This one here. X should be the top number there. It should be our speed. But what I see is maybe I need a blinker input. Like that, and then maybe I need to put a blinker on the ship. Sometimes that's the way it is, right? We have to combine different elements. See if that works. Well, what is going on? This timer, yeah, should every second we should be getting that value. So let's pass that value on to channel 2, and let's see what that distance is. There it is. It's funny how here it's so that's the, oh yeah, because we're subtracting. All right. So if we subtract then this number from that number, still negative. All right, so that is it's working. It's giving us our distance. We'll take that and that, and we are getting. So this is working. The direct distances are working. Back to square one. Let's see. Back to square one. And the basics working. Whew. There we go. Oh. It kind of worked. It kind of worked. All right, we'll load the autosave. All right, so you kind of get the idea there. So we got the distance. Yeah, see, I'm wondering about that. This, let's get some more music going here. I was wondering about this, if I just divide it by 1, maybe if that's going to help. Right, because I could just tell it to take that number. I can say speed equals distance x divided by 1 for every tick. I wonder if that would work. Speed x. And then if on here I put speed x make sure it's connected, and then that's speed x equals, yeah, let's try that. Nah, it's not working. I'll have to look at the shuttle. I did the calculation on the shuttle. I'll have to take a look at it just to see what's what. The speed. I think I had to set it up manually where I actually had to press a button to get it to calculate the speed. Alright, so that's fine, that's fine. We'll just set that back to 6. And get rid of that, and that, and that. Okay, so then in the code, we're not going to worry about this. But we'll have our distance. And this can be y. So when we press the button, it's going to give us our XYZ. And then it should also give us our current XYZ. So we should have 2 sets of numbers there. And they should be the same if we don't move. Yep, there we go. And then if we start to move, it'll tell me how far off of these distances I'm moving. Alright, so we got that. So we know how far back and forth we need to go. So moving on from there, everything else is kind of not really working. So we don't need that. Got the numbers, we're sending them out. What's next, I suppose, is trying to, we need to calculate our linear speed. Really, that's what I need to do next. Okay, so we're gonna update this, and I'm gonna save this. I'm going to load the shuttle. Because I think I had to set it up on a timer. So when I push the button, it waits 3 seconds. Yeah, that's what I had to do. So I don't even need to load the shuttle. So what we need on here is we need another push button. So we'll put one here. And that's going to be like that. And then into here we'll convert. Which one aren't we using? Just the blank input. Is that this one here? Yeah. This will be speed. Alright, so then this push button will come in. And what it will do is it will subtract. So how are we doing it in the code? We are subtracting our saved number first. And then we're subtracting that from this number, the actual number. Okay. And once we have that number, we then need to divide it by time, the distance it takes. So we need to take this number, we need to save it, so that's the distance. We need to save that number. Let's see. Yeah, we need to save that number. And then we need to wait. So we need a timer. There we go. Start and reset. So it should start, and when it's complete it'll reset, and then it should wait. Constant number 3, and when the timing is complete it resets, and hopefully it will, we can then subtract the saved number no, we need some switches here, I think. We need some switches here. Alright, so the saved number, I don't know what the heck I'm trying to do here. I need to divide this number by, I don't know what I'm trying to do here. I don't know what I'm trying to do. I'm trying to get the linear speed. So we need to take the distance and the time it takes us to travel that distance. So I need to take a measurement over 3 seconds. So we need to mark our position, and then in 3 seconds we need to mark our position again. So I think we need a second set of memory is what I'm getting at here. And what we're going to do is we're going to mark the position when the timing is complete. We'll mark that position. Then what I can do is I can subtract that position, the new position, from the old position. And then I can divide that number by the timer. And that should give me the linear speed. Just like that. So that linear speed, let's let's output it. Let's output it. Just so you can see how accurate it is. It is going to be X. We'll just choose X. And then we need a dial. So now I'm going to get rid of that, and I'm just going to put the dial there. Something's not going on. Maybe I chose the wrong input. Oh, that's right. So let's make sure I got the button even connected. I might not even have the button connected. It's coming from the blinker. Which I suppose could do the same thing, really. It could blink every 3 seconds. That's an awfully big number. But it would kind of make sense in that one of these numbers isn't being passed through. Well, it must be. Let's see what that number is. So that is just the current X value, which is not what we want. Why is that? That's the current X value. But it should be try that. Could be in the way that the numbers are being manipulated. Should be 0. It should be 0. Oh, let's think about this. So we have our timer. I think the problem here is, I think I'm looking at the wrong numbers. Yeah. Because that number isn't being passed through. So we'll turn on the timer. It probably has to do with that, with the reset. Now, when it presses the button, it should wait 3 seconds, and then it should save our current distance. And then that number should go out to there. But for some reason, it's not. That number is saving. I suppose it should be 0. If it's working properly, it should be 0. If it's working properly, it should be 0. Oh no, it shouldn't. That's odd. Timer enabled. Now, does this need a constant number? Or a constant on signal? questions I do not have answers for. Okay, so with the constant on signal, it saves. So why won't it work with the... Ah. So when it turns on, it needs to have a constant on signal. So if we do that and then that, then is that going to put it into a loop? Yeah, look at that. Every 3 seconds it updates. Perfect. So if every 3 seconds it updates, now we can do this math. And we should be able to do that. And get a linear speed. Yeah. There we go. That's our linear speed. Oh, that's perfect. And that's in meters per second. Excellent. So there you have it. So we created a linear speed thingy in a very late night video. I hope it didn't crash. I guess I'll have to check on that. Well, that's going to do it for today's video. Thank you so much for watching, liking, and subscribing. And I will see you all in the next one.